So questions, comments? I'll be around. I think I don't have appointments till 6. Ethan.
This was what I was kind of confused about at the beginning when I asked that question.
Mm-hmm.
The envelope, the exponential envelope was a complex sinusoid to itself, but it's actually a complex amplitude.
Yeah. Yeah. So it's e to the st where s has a real part that gives an exponential growth or decay, and it's z to the n where z is magnitude other than 1 gives you the exponential growth or decay. And that's when we call it, so we can't call it a sine wave anymore because a sinusoid it oscillates forever at a steady amplitude. But since these will now grow or decay exponentially, we can call them generalized sine waves. We could also call them just exponentially decaying or growing sine waves. That would be a longer name that would be more descriptive.
Sinusoids with complex frequencies.
Yes, you can do it. And that's what happens in physics. In physics, they allow frequency itself to have an imaginary part. And because you're multiplying it by j, that turns the imaginary part of the frequency into your time constant of decay term. So engineers use sigma plus j omega. Physicists use omega going complex. So you allow imaginary frequencies, and it ends up being the same stuff. Different convention for handling it. Yeah. In physics, a really interesting topic. So I'll just throw out one last topic to search on your own in your copious spare time. Check out evanescent waves. Have you ever studied evanescent waves?
This was in one of the videos, the lecture page, one of the lecture videos. There's an evanescent wave.
I definitely covered it at some point, somewhere. So I'll just say it's cool because it basically is a case where frequency goes imaginary spontaneously. So you're basically doing some math of reflection. So you basically got an interface between two different materials where speed of propagation is different, and you send a plane wave into it, and it partially reflects, partially transmits. You have your total reflection angle and stuff like that. Well, in the math, when you see the total reflection angle, you get this amazing magical thing that the waves going through the interface are non-zero, but have imaginary frequency. And so it's just this weird mathematical thing that falls out, And so you think, well, that's got to be, math must be breaking down. It can't be real. Turns out it's real. Turns out that reality does it. And so these are called evanescent waves. There's no power propagation. There's no energy delivered by them. And they're really amazing. So check them out. They exist, and they can cause phenomena. But mathematically, it looks like a total breakdown of the math, and that's the end of the story. But no, reality follows that. Actually does it. Imaginary frequencies become exponential decays with no power propagation. So check it out. It's an amazing topic.